Alright, so when dealing with graphing rational functions, there's a lot of things you have to consider, a lot of work you would have to do to get the information that you needed in order to graph. Now, just to review, for horizontal asymptote, if your top degree, meaning top exponent or numerator exponent, is less than your denominator exponent or bottom degree, it will always be y equals 2. That's your horizontal asymptote. If the numerator exponent, top degree, is the same as your denominator exponent or bottom degree, all you're doing is you just divide the coefficients of the highest exponents from the numerator and your denominator. That's all you're doing, just divide the coefficients. So your top degree, if it's more than, greater than your denominator exponent bottom degree, there are no horizontal asymptote. Now, the special case that was discussed in class, top degree plus 1, meaning 1 more than your denominator degree. So if this was 4 and it was 1 more than 3, or this was 5 and this is 1 more than 4, then you have a slant asymptote. In order to find slant asymptote, you have to do long division. So keep in mind about these information. Now, asymptotes are basically just lines or guidelines on the graph where your graph does not cross. So again, asymptotes, if you have a vertical or horizontal asymptotes, they're basically dotted lines you see on the graph, and acting as guidelines, meaning that your graph, any function that you graph, won't cross it but goes towards near it. That happens most of the times. Again, 99% of the time, it won't cross. Just go near it, but not cross. So let's talk about the first example. Alright, here we have x to the third plus 5x squared plus 2x minus 8 over x minus 3. Now, we can see that the highest exponent in our numerator, or top degree, is greater than the denominator exponent, or bottom degree, which is 1 right here. So 3 is more than 1. So if we go back to this, so we look at this one, top degree is greater than bottom degree, so there are no horizontal asymptotes. So if I were to write that out as my supporting information for graphing, so again, top degree was more than bottom degree, then the rule is our h of a, horizontal asymptote, is y, nope, there are none. So there are no horizontal asymptote. Alright, let me box that up, saying that this is our information when it comes to graphing. Alright, so there are no horizontal asymptote. Now, let's do the vertical asymptote. Vertical asymptote. So vertical asymptote, just like how we did in class, all you're doing is extend the factors from your denominator equal to 0. So we have just one factor, x minus 3. So x minus 3. Let me zoom in for you. So x minus 3 equal to 0. And then just solve for it. So plus 3 plus 3, x equals 3. So that's our vertical asymptote. So let me write right here, VA, x equals 3. And again, let's box that up because we're going to need that information when it comes to graphing. Alright. Those two information are not enough when it comes to graphing. Now, again, here it's x to the third plus 5x squared plus 2x minus 8 over x minus 3. Now, when you factor using multiple methods, one, you can do synthetic division or long division, but it's easier with synthetic division or grouping, especially with x to the third power. When you factor or do synthetic division, you will get x minus 1 times x plus 2 times x plus 4. So those are your factors for your numerator. Now what we can do is find the intercepts, the x-intercept to be precise. So what we can do from there is we're just going to look at the three factors for your numerator. So in order to do x-intercepts, you only look at the numerator. That's it. Now y-intercept is pretty easy. If we were to do y-intercept, all you do is plug 0 into x. So we're going to do some work for x-intercepts, and then we're going to do a work for the y-intercept. Now again, in order to do x-intercepts, all you're doing is just look at the factors in your numerator. That is it. Now for the y-intercepts, you're going to plug 0 in all the x's, so you will see that. So I'm going to do some work for the x-intercepts. Alright. So let's write out our factors. X minus 1 times x plus 2 times x plus 4 over x minus 3. Now, again, we're doing the x-intercepts. So, I'm going to write right here x-intercept So when we're doing x-intercept, we're just going to focus only the factors in your numerator. The factors in your numerator. So x minus 1, x plus 2, and x plus 4. So let me put some space. X plus 4. So when again, finding x-intercept, all we do in here is just set it equal to 0. Okay? So, it's kind of like doing vertical asymptote, but this time we're only doing for just the x-intercepts. And you see the difference at the end. So we're going to solve for each x. X equals 1. And the last one, x equals negative 4. Now, again, this is just the x-intercept. So, remember, x-intercept is always a coordinate point. So, x, comma, y. So, if we find all the x-intercepts, now the only thing that's in common with all the x-intercepts is that it's going to be along the x-axis. That means that if it's along the x-axis, the y value is always 0. So here, our x-intercept is 1, comma 0. Second one, our x is negative 2, so it's negative 2, comma 0. And our last one, x equals negative 4, so it's negative 4, comma 0. So that is our x-intercepts. 1, 2, 3. So 3 factors. So if I were to go back to this chart that I made for the XY table, if we look at 1, the y value is 0. So let me go over here and write 0. And then at negative 2, it's also at 0. So I'm going to write at negative 2, 0. And then negative 4 is 0. So I'm going to write 0 here. So pretty much we have like almost half of our information when it comes to graphing. We need to plug in these points to find the other values. Now, y-intercept is you plug 0 into x. So here's the work to do x-intercept. Now we're going to do the y-intercept. So the y-intercept and the one thing you always remember, or should remember, that for the y-intercepts, x is always 0. So remember, intercepts, x or y is always a corner point, and we already know that x is always 0 and a value for y. So since x is always 0, we're going to plug 0 into all the x's. Now in the original function, it's x to the third plus 5x squared plus 2x minus 8 over x minus 3. Now, all we're doing is just plugging 0 into x. And again, this is for the y-intercept. So, I'm going to put 0 to the third power plus 5 times 0 squared plus 2 times 0 minus 8 over 0 minus 3. So again, all I did was plug 0 into all the x's. That's all I did. So we're going to do all the exponents. So 0 to the third power is just 0. Here is 0 squared. So 0 squared is just 0. So I'm going to put just 0 without the square. So again, all I did was work out the exponents. Now, if I were to work out, okay, these two right here, 5 times 0 is 0. So let me bring down the first 0. 5 times 0 is 0. And then do 2 times 0, that's just another 0, minus 8 over 0 minus 3. Okay. So pretty much we're done with exponents and multiplying, because here 5 times 0 is 0, 2 times 0 is 0. So again, don't have to worry about exponents, don't have to worry about any multiplications. Now, all we do is just focus on the top. 0 plus 0 plus 0 minus 8 is just negative 8 over 0 minus 3 is just negative 3. Alright, so here's our y-intercept, basically negative 8 divided by negative 3. Well, that means it's a fraction, so we can convert it into a decimal value. So, one thing we know for sure is that a negative divided by a negative becomes positive. So, if we do 3 divided by 8, so just like how we were evaluating a function, 3 goes in 8 2 times. So 2 times 3 is 6. And we're left with 2. Now we can't just end there, so I'm going to put a decimal, add a 0, bring it down, and this is a 20. Now, so 3 goes into 20 6 times. So 6 times 3 is 18. Subtract, I'm left with 2. So it's pretty much the same as this one. So if I add another 0, it's 20. So that means basically it's going to repeat. So I'm going to put another 6 right here to be precise. So negative 8 over negative 3 is just basically 8 over 3, or in decimal value, 2.66. Well, when it comes to graphing, we're just going to use 2.6. So, our y-intercepts, so we plug in 0 into all the x's, and then we came out with 8 over 3. A positive 8 over 3. Remember, negative divided by negative is positive, so 8 over 3. And then if I would convert it into decimal, we got 2.66. But I'm just going to write 2.6. So 2.6. Now all we need to do is find the other points. So again, this is our y-intercept, x-intercept, x-intercept, and x-intercept. So all we have to do is plug in negative 3 and 2. Right, so the original function was x to the third plus 5x squared plus 2x minus 8 over x minus 3. So we're going to plug in, say, 2 first, right here. We're going to plug 2 into all the x's. And of course, you have to follow PEMDAS carefully. So we're going to plug in 2 into all the x. So 2 to the third power plus 5 to square plus 2 times 2 minus 8 over 2 minus 3. Alright, so 2 to the third power means that is basically, and right to the side, 2 times 2 times 2, which is 8. Because if we do it part by part, 2 times 2 is 4, and then 4 times 2 is 8. So I'm going to write right here. Now, again, we do exponents first. So 2 squared, that's 4. And then we times by 5 because it's on the outside. So 2 squared is 4, and then 4 times 5 is 20. And then here, so plus positive 2 times 2, that's just going to be a regular 4, and then minus 8 over 2 minus 3, which is negative 1. So that's a good thing. Make the work less. Alright, so here we do 8 plus 20, that's 28, plus 4, that's 32. And then we do 32 minus 8, which is 24, over negative 1, which becomes negative 24. So we got our y value when we plug in x equals 2. So here we're going to write negative 24. Now we're going to plug in negative 3. That's the only value we have left. Alright, so again, we're plugging in negative 3. So, negative 3 to the third power, and see how that I'm putting in parentheses. And again, I put parentheses because I'm plugging in a negative number. Now, focus on the exponents only, or first. So negative 3 to the third power. So if I write right here, negative 3 to the third power is basically negative 3 times negative 3 times negative 3. So we do negative 3 times negative 3, that's a positive 9. And then a positive 9 times negative 3 is negative 27. So I'm going to write negative 27 here. Alright. And again, we're doing exponent. So negative 3 squared, just like this one right here. So negative 3 squared, basically a positive 9. And then positive 9 times 5 is a plus 45. And then 2 times negative 3 is going to be minus 6. Because again, we have a positive 2 times a negative 3. And then a minus 8. Over, we have negative 3 minus 3. So that's negative 6. Alright. There's a lot of negatives combined with a positive number. So, what I'm going to do is combine all my negatives. So, negative 27 minus 6, that's negative 33. And then minus 8. So, negative 33 minus 8, that's just basically negative 41 plus 45 over negative 6. So, if I work out the top, negative 41 plus 45, that is just basically a positive 4 over a negative 6. And if we were to simplify, because 4 and negative 6, they're both even numbers, it becomes negative 2/3. And then we already know that a 2/3, the decimal value is 0.066. So if it's negative 2/3, we know that it's going to be negative 0.66. But we're just going to use negative 0.6. So we plug in negative 3. So our y value is negative 0.6. So negative 0.6. Alright. It seems that we have all the information we need. Vertical asymptote, horizontal asymptote. We have our 3 x-intercepts. We have our y-intercepts, and then we have our 2 points that we need to graph. So now we're going to use the center as the x-intercept and the y-intercepts. So I'm going to mark it, saying that this right here is the x-axis, and here is the y-axis. And this is the center, the origin. Alright. Now, if we were to do the vertical asymptote, well, let's take a look. Horizontal asymptote, that means there's no horizontal lines. But we do have a vertical asymptote, x equals 3. So that means it's going to be a vertical line, or vertical dial line. So here, at my origin, we're going to look at 1, 2, and 3. So, zoom in. So, in the center, 1, 2, and 3. So at 3 is going to be a dotted vertical asymptote. So that means that the graph won't cross. It will go near, but won't cross. Alright, so looking at the information again, so we got our vertical asymptote and our horizontal asymptote. Now we just need to plot these points. So let's do the x-intercepts. 1, 0, negative 2, 0, and negative 4, 0. So again, we're just going to plot the x-intercepts. So at 1, 0, so right here, this is 1, 0. And then at negative 2, 0, so here's my origin, 0, 0, negative 1, negative 2, 0. And then we have negative 4, 0, so negative 3, negative 4. Alright. So that's our x-intercepts. Now, our y-intercept is going to be 2.6. Now, it's a decimal, so that means that it's going to be hard to be precise. But here's our y-axis, so x equals 0. Now, our y-intercept is 2.6. So 1, 2. Now, 2.6 is more than halfway between 2 and 3. So I'm just going to mark it between 2 and 3, but close to 3. So that's our y-intercept. So here's 2 and here's 3. And again, let me zoom in for you. Here's 2 and then here's 3. So 2.6 is between that, but it's more than halfway. So that's how you would graph a decimal value. Now, our next one is going to be negative 3, negative 0.6. So what we're going to do is we're going to look at negative 3. So negative 1, negative 2, negative 3. And then it's at negative 0.6. So it's going to be below. It's going to be between 0 and negative 1. Again, 0.6 is more than halfway towards negative 1. So I'm just going to mark it right there, where it's more than halfway to negative 1. Alright, now our last one is where it's 2, negative 24. So 2, negative 24 basically means it's going to be all the way at the bottom here. Now if I were to count, 1, 2, 3, well, negative 1, negative 2, negative 3, negative 4, and so on, it's going to be somewhere down here beyond the graph. So I'm just going to mark anywhere below here. So here's our x-intercepts, and then here is our y-intercepts. Here's a point, negative 3, comma, negative 0.6, and we're going to graph. Alright, so basically we're just going to follow in order. So starting with 2, negative 24, we're going to start there. And then it's going to hit 1, 0. So I'm going to go up to, from this point, to 1, 0. And then I'm going to hit the y-intercept 0, comma 2.6. So I'm going to go through it. And then I'm going to do negative 2, comma 0. So I'm going to go back down. And then after that, it's going to be negative 3, comma negative 0.6. So I'm going to go down. And then I'm going to hit at negative 4, 0. So I'm going to go back up. And then I'm going to just go straight up. So here is our graph for a rational function. Now it doesn't have to be perfect as long as it's precise. Again, this one right here is the origin, 0, 0. So if you were to type this in Desmo, you would see a much precise graph, but it's going to be similar to what we have here. So here's a vertical asymptote. Now again, this graph right here is going to go towards the asymptote, and as you go down further to the negative infinity, you will see that the graph will get closer to the asymptote. but won't cross it. Now this, again, if you type the function, if you're to type this function into decimal, the website, then you will see a precise graph, but it's going to be almost identical to this, what we have here. So again, this is a graph for this function, x to the third plus 5x squared plus 2x minus 8 over x minus 3. And then for rational function, you always have to do the horizontal asymptote, vertical asymptote, find the x-intercepts, the y-intercepts, and then additional points in between when it comes to graphing.